Okay, in this lesson of 7.3, we're going to be solving addition and subtraction equations. A term that you're going to use quite often is inverse operation. An inverse operation is an operation that undoes another operation. Example, addition and subtraction are inverse operations. Number 2, subtracting the same number from each side of an equation produces an equivalent equation. So these two are going to be very important in this lesson of solving addition and subtraction equations. So to solve an equation using inverse operation, you find the side of the equation with the variable and undo the operation that has been done. Your goal is, this is a hint, your goal is to get the variable alone on one side. You will hear me say over and over again, our goal is to isolate the variable. Our goal is to get the variable by its side to solve the equation. So remember, what you do to one side of an equation has to be done to the other side. In this first example, if x plus 5 is equal to negative 3, we're going to do the inverse operation. We're going to undo this equation. So in this first example, we're going to subtract 5 from each side. We're subtracting 5 from each side of the equation because we're trying to isolate the variable. So if I subtract 5 from the left-hand side of the equal sign, all I have left is x. Then negative 3 minus 5 is negative 8. So x is equal to negative 8. In our second example, we have c plus 3 is equal to 10. We're going to undo this, so we're going to do the inverse operation. So I'm going to subtract 3 from this side of the equation, and I'm going to subtract 3 from this side. So all I have left on the left-hand side is c. 10 minus 3 is 7. So the solution for the second example is c is equal to 7. Okay, so in example 4, we're going to solve each equation using the inverse operations. So we're going to undo. We're going to do the opposite. So what we do to one side of the equation, we have to do to the other. So in 4a, we're going to add 3 to this side. Then we're going to add 3 to this side. If it helps, draw a line. Negative 3 plus 3 is 0. So all I have on the left-hand side is going to be y. You don't need to put y plus 0. Bring down my equal sign. 8 plus 3 is 11. In B, again, my goal is to isolate the variable. So I'm going to subtract 6 from this side of the equal sign. I'm going to subtract 6 from this side. 6 minus 6 is 0, so all I have left on that side is x. Then I have negative 15 minus 6 is negative 21. So x is equal to negative 21. In C, I have an a that I need to isolate. So I'm going to add 5 to each side. So 12 plus 5 is 17. That's going to equal a, because negative 5 plus 5 equals 0. So you don't need to put there a plus 0. In D, inverse operation, I'm going to add 15 to this side of the equal sign. I'm going to add 15 to this side of the equal sign. All I have left is r is equal to negative 8 plus 15 is going to be 7. If you get confused, you can write it out to the side, negative 8 plus 15. 7. On E, Again, your goal is to get that variable by itself. So I'm going to subtract 42 from each side. (42) minus 42 is 0. Negative 20 and 5/10 minus 42 will be negative 62 and 5/10. If you need to come out to the side and work it, you can. And last example on this page, I'm going to add 12 to each side. Negative 9 plus 12 is going to equal to 3. So I have 3 left on this side is equal to y, because negative 12 plus 12 is 0. In our next set of examples, I'm going to subtract 29 from each side on this example. A is equal to, again, I can do 41 minus 29. 41 minus 29 is, so A is equal to 12. So in H, I'm going to add 2.3 to each side. 3.6 plus 2.3 is 5.9. Negative 2 and 3/10 plus 2 and 3/10 cancel each other out, so it'll be a 0. So you don't have to put the 0. So in I, I'm going to add 6 to each side. Now I have negative 8 plus 6. Negative 8 plus 6 is going to be negative 2 is equal to M. So notice on this one, on J, we're dealing with fractions. So I'm going to add 3/8 to each side of the equal sign. So I'm going to have N left over on the left-hand side. In order to add with fractions, we have to find the common denominator. Now I'm noticing I'm adding 16 plus 9 is going to be 25 over 24. That's going to equal to 1 and 1 over 24. So N is equal to 1 and 1 over 24. Notice in K, I have a double negative. So I want to encourage you to rewrite this adding the opposite. Same with N. Excuse me. Adding the opposite. Rewrite it. So that will help you to determine what the inverse operation is going to be. In K, now I'm going to subtract 7 from each side. Don't let this confuse you. Now I have negative 7. Minus 7 is negative 14. Now that's equal to B. I'm going to go ahead and hop down to M and do the same thing. I'm going to subtract 6 from each side. Negative 13 minus 6 is negative 19, and that's going to equal to Y. On L, we will subtract 2/3 from each side. X is equal to, now notice, we need to find a common denominator, so we'll change that to an equivalent fraction of each having 15. So 5 times 3 is 15. 1 times 3 is 15. And our new numerator will be negative 10. So now we have 3 minus 10 is negative 7 over 15. Number 5, when like terms appear in an equation, combine the like terms and solve the equation. So in this example, noticing my like terms are 3t and negative 2t, so we combine those two. We just have t. because 3t minus 2t equals 1t, which is the same as t. So now we have t plus 4 then we'll subtract 4 to each side to isolate the variable. Now we have 2 and 2/10 is equal to t. So let's do some problems involving combining the like terms. Instructions say solve each equation using inverse operations. Check your answer. So in A, we're going to combine our like terms, which will be our constant terms. So 2 is equal to 1.3 plus 4 is equal to 5.3. So we have 5.3 plus A. We combined our like terms and got 5.3. Now we're going to subtract 5 3/10 from each side of the equation. If you need to again go out to the side, you can. You can. Notice that they're different signs, so you'll subtract. Your answer here will be negative 3 3/10 because you took 2 and subtracted 5 3/10, and that will equal A. In B, I'm going to combine our like terms. 3 4/10 minus 1 3/10. That will equal 2.1. Inverse operation, I'll subtract 2 1/10 from each side. D is going to be equal to 4 7/10. Okay. Combine the like terms. So 4 2/10 minus 1 4/10 will be 2 8/10. Inverse operation, I'm going to subtract 2 8/10 from each side. So after checking, I noticed I needed to correct my answer. So K is equal to 4 7/10. On D, 2 minus 21 is equal to negative 19. So now I have negative 19 plus R is equal to 14. Add 19 to each side. R will equal 33. Now I'm going to pause the video, work these. First I'll combine my like terms and we'll come back and check our answers. Now as you notice on E, we need to combine our like terms, which will be the constant terms of negative 1/2 plus 2/3. Again, using the rules, we notice they're different signs, so we'll subtract. So we're taking 2/3 and we're going to subtract 1/2. Finding a common denominator of 6. 2/3 is equal to 4/6. 1/2 is equal to 3/6. So we're taking 3/6 away from 4/6, which gives us 1/6. Bringing it back over to our original equation, now we have x plus 1/6 is equal to negative 5/6. Doing the inverse operation, we're now going to subtract 1/6 from each side. So what we have left on the left-hand side is x is equal to, then we have negative 5/6 minus 1/6, which gives us negative 6/6, which is equal to negative 1. So x will be equal to negative 1. In F, our like terms that we're going to be combining before we can solve it is the coefficients. So the coefficients are 6x minus 5x, which will leave us with 1x, or just x. 1x plus 4/5 is equal to 2/7. Doing the inverse operation to isolate the variable, we're going to subtract 4/5 from each side. Doing that, we need to find a common denominator for 2/7 and 4/5, which is 35. Finding equivalent fractions of 10/35 minus 28 over 35. They're different signs, so you will subtract. So if this helps you for the numerators, please write it out there till you get the hang of being able to see it. Knowing it's going to be 10 plus negative 28. For different signs you subtract and you get negative 18. So the final answer for F is going to be x is equal to negative 18 over 35. On our final example on this page, on G, again we're going to combine our coefficients. Notice we have 2x minus x, which leaves us with 1x, or just x. So now we have negative 8 plus x is equal to negative 12. Inverse operation, we're going to add 8 to each side. Negative 12 plus 8 is equal to negative 4, so x is equal to negative 4. In this next problem, write and solve an equation to find the unknown length of the side using a variable. Here we're going to use the information that has been given to us. To find the perimeter, you add all the sides. So if I have 3 feet plus 4 feet plus x will equal 12 feet, as it's been given in that problem. So now I'm going to combine my like terms. 3 feet plus 4 feet is 7 feet, plus x equals 12 feet. Inverse operation, I'm going to subtract 7 feet from each side. X is equal to 5 feet. Again, in order to receive full credit, you need to show each and every step. In our next problem, solving the perimeter, solving for the x using the perimeter, 7/10 plus 7/10 plus 1 8/10 plus 1 8/10 plus x is equal to 6 millimeters. Notice that all of my measurements are in millimeters, so I don't have to convert anything. So when you add, let's do the 7/10 plus the 4/10. Excuse me, 7/10 plus 7/10 is 1 4/10. Plus, and then we'll combine the next two, 1 8/10 plus 1 8/10, which gives me 3 6/10. When you combine each of those, 1 4/10 plus 3 6/10, you get 5. So 5 plus x, we combine these two to get the 1 4/10. We combine these two to get the 3.6. Then we added those two and got 5. So we have 5 plus x is equal to 6 millimeters. We're still needing to solve for x. So we're going to subtract 5 from each side. X will be equal to 1 millimeter. So the missing measurement is 1 millimeter. In 8, write the verbal sentence as an equation, then solve the equation. So this is a review. We have the difference of a number and b is negative 15. The difference of a number, b, and 8 is negative 15. Inverse operation, we will add 8 to each side. B is equal to negative 7. 9 more than a number x is 24. Inverse operation. So remember, when solving addition and subtraction equations, we will be using the inverse operation.